So I want us to start reviewing for the test, and so first we're gonna go into lesson 20.1, and I want to go into the second your turn question, as you can see right here. I'm gonna turn off the light a little bit so you can see the screen. It would really help you if you take out your paper and pencil and start taking notes on these things. So let's take a look over here. This is the first your turn question. So I clicked up here in 20.1, and then I went into the second your turn question right here. All right? So let's read the question. It says find the value of the variable that results in congruent triangles. Okay? So then we already know that these two triangles are the same. Well, how do we know that they are the same, guys? Because what? They look the same, but yeah, if you want to move your desk, go ahead and move it. Sit next to somebody who's smarter than you. Okay, so if you see EF, this one has 2 tick marks. That would be the same as segment BC. They would be congruent to each other because this one has 2 tick marks as well. In the same way, look at this. Segment GE is going to be congruent to segment BD because look, they both have 3 tick marks. Finally, segment GF is congruent to CD because they both have 2 tick marks. So for those of you who remember, these 2 triangles are congruent to each other because they have 3 sides that measure the same length. And so they are congruent to each other because of the SSS congruence postulate. Okay? And of course, I'm going to write this down for you. SSS congruence theorem or postulate. Okay? So there you go, because we have 3 sides that measure exactly the same. Alright? So then now it says what? The value of x that will result in congruent triangles is what? So we gotta find out what x is equal to. As you can see, we have 23 degrees and we have 114 degrees. So in order for us to find x, we gotta figure out how big this angle is. Okay? So that's orange and you can't really see, so I'm going to change it to black. You got to find the measure of these 2 angles, which is the same, in order to find out what x plus 17 is equal to, right? Okay, so then tell me, just looking at this triangle over here, how can I find the measure of this black dot, this angle right here, Cassandra? Cassandra, tell me, when you add all 3 angles together in a triangle, they have to add up to be how many degrees? Yes, it's supposed to be 180 degrees. In other words, the black dot, which I'm going to just draw literally right here, plus 114 plus 23 has to equal 180 degrees, right? So what we're going to do is we're going to add these 2, and that's going to give me the black dot plus 114 plus 23 is what, guys? Oh gosh, thank you for your awesome answer. Like I hear nothing. Alright, so now I want to find out how big my black dot is. So what do I do to both sides now? Yay, thank you. Now this time I really have answers. You subtract 137 from both sides. So now my black dot is now equal to what? No, if you subtract this, this is 3, 7 minus 3 is 4. Yay, I know how to subtract. So my little dot is 43 degrees. Thumbs up if you get it so far. Oh, I love it when you guys are like all participating. Thank you. And so this black dot is now 43 degrees, right? Okay, so I'm so happy I figured out how big this is. And so I know that this black dot, because these 2 triangles are the same, is also going to be 43 degrees. But the question asked me what x is equal to, didn't it? Okay, so then how am I going to figure out what x is equal to? Can somebody tell me? Is a good start. Anybody else? Huh? Oh, what? I know you're going somewhere, but let's elaborate. You said 43 minus 17. You said 43 plus 17. I know that you know that you gotta use x plus 17 and the 43, right? But how are we gonna use it? Come on, Ignacio, it's too easy for you. You're just giving the answer. Okay, so what Ignacio was trying to say without giving the answer was x plus 17 is equal to 43, because that's the measure of this angle, x plus 17, and the measure of this angle is 43 degrees. So these two have to be the same, right? So x plus 17, equals 43 degrees. And so then I gotta subtract 17 from both sides, which is what Armando said, right? And so now x is going to equal 26, like Ignacio said. He wanted to give the answer to you. So then what I'm going to do now is obviously go ahead and put in my answer. And I think Ignacio said 26 degrees. Now I'm going to check my answer, and of course it's correct because Ignacio knows his math. All right. So now what I want you to do is, based on what you just learned, try and solve this question right here in 20.4, the third your turn question, okay? And I'm going to give you some time to do this. Okay? Ready? Go. Okay, so Craig made a mobile using geometric shapes, including triangle shaped as shown. For what value of x and y can you use a triangle congruence theorem to show that the triangles are congruent? And then you gotta, complete all of this stuff. And so just looking at the two triangles, let's take a look, guys. I have, let's see, I have a 90-degree angle. And that is the same as this 90-degree angle. And then I have 30 degrees right here. And then I got 60 degrees right there. That tells me that those two angles are not the same, right? So I gotta figure something else out. Well, this angle here and that angle there, they have variables in it. I don't know what to do. So let's just try and use common sense. If this is 90 degrees, right? Because we know that little square thingy means it's 90 degrees. If this angle here is 90 degrees and this is 30 degrees, how big is this angle right here, guys? How did you get 60? Okay, so your explanation did not make any sense, but that's okay.
All shapes are equal to 180 degrees.
Yes.
Because right there on F it says 60.
Okay, so the reason why this is 60 degrees is because all three angles inside the triangle need to add up to be how many degrees, guys?
30.
No, 180. So it's going to be 30 plus 90 plus this angle right here, and of course I'm gonna and then that angle right there is supposed to equal what? 180, right? So when you add these together, it's 120 plus that angle, and so that's 180. So subtract 120 from both sides. And so now you know that that angle is 60 degrees. I know I should use x because now we're in high school, but sometimes I just want to use drawings. So there you go. That's how I know that this is 60 degrees. And so that tells me this angle and this angle is the same, isn't it? Right? There you go. So this angle and that angle is the same because they're both 60 degrees. And so then we know that this angle is how many degrees, guys? 30 and 30. Okay? But I'm not going to highlight that right now. And then what else can you see? Hush, babies. Okay. Well, we're not sure if this is congruent or not, but we gotta make sure that we find a value of x that's going to make these two triangles, x and y, that's going to make these two triangles the same. Which means that we need to have all three angles measure the same. So this 30 degrees is this 30 degrees, right? So all three angles have to measure the same. And obviously this side between the red and the yellow angle. And then these two sides between the green and the yellow. And this side between the red and the green. They all have to measure the same, right? So then now I'm going to go ahead and erase all this because I have no space. Okay guys, so tell me, how am I going to figure out what y is equal to? What did you say?
Either divide or subtract.
Divided by what?
Divide or subtract.
Oh, I think I know what you're trying to say, but you're trying to explain the process and not the equation. So what's the first equation I have to write here? 60 degrees is the same as what? As this one right here, okay? So you're going to say 7y plus 4 equals 60 degrees. That's how you're going to set it up, Veronica, okay? And then you subtract the 4 and divide by 7, okay? So you correctly explained the process, but did not set up the equation correctly. So there you go. It says this red angle over here is 7y plus 4, and we figured out that it's 60 degrees. So in order for us to find out what y is equal to, we have to say 7y plus 4 is equal to 60 degrees, right? So from here, I'm going to go a little bit fast because, you know, by now you're sick and tired of me doing middle school stuff all the time. And, you know, Veronica already explained the process anyway. So we already know that y is 8, and that's the answer that goes there. So then the x is going to be, it says 9x minus 10 meters. That's this side in between the yellow and the green. That's this one right here, in between the yellow and the green. And these two sides have to measure the same. So how am I going to set that up in order to find x, guys? Oh, what did you say? What did you say?
9x equals 10 equals 30 degrees.
That's this side that goes with that side equals what?
Oh, 8.
Equals 8. Good job. So I'm going to erase this now. Are you okay with me erasing this? Okay. Can I erase this now? So Veronica is quickly becoming my favorite kid, right?
Isn't the next one equal to 30?
No, that 30 degrees, that's the blue, the green angle
the
right
other
here.
shape. That one.
Yeah, but no, this one right here, oh, it's because you cannot see. This one says 9x minus 10 meters, not degrees. Okay, so that would be the length of this red line right here, in between the yellow and the green angle. Okay, that's why. So 9x minus 10 equals 8. All right, so somebody already told me the answer. You add 10 to both sides, so 9x is 18. And then we divide both sides by 9, so x is equal to 2. So I'm going to put 2 here, but I still have to fill out the rest of the stuff. So let's see, measure of angle H is how many degrees, guys? The green angle, how big was that one? That's the same as that green angle, so it's going to be? Yeah, 30 degrees by the triangle sum theorem. So angle H and V is congruent to each other because they have the same measure. So angle G is angle U. G and U, are they the same? Yeah, so we're going to say that they are congruent to each other because they are both right angles. If GH is UV, if GH, this red line is UV, this other red line, then these two triangles are congruent by the, what theorem, guys? We just did an angle. We did this angle, that's an angle, right? And then we also talked about G and U, that's another angle. And then we talked about the side in between. So it's going to be what? Angle, side, angle. So it's going to be ASA theorem. Okay? So let me just go ahead and fill everything in. because we're finally done. And guess what? The textbook is going to tell me that I am wrong because the textbook answer is wrong. That's why I'm doing this question with you, okay? So this is 2, and this is 8, and this is 30 degrees, and they were congruent, and this was ASA. Uh-oh. Wait, it said it's correct, but no. Earlier, when I solved the question, the answer was wrong, but anyhow, go ahead and fill this in, okay? So now I'm going to go ahead and pause my video again. So this is the next question I want to go over with you today. This is the second your turn question in chapter 21.2. I'm going to give you time to copy the question. Ready? Go. Okay, so a lot of you know how to find segment lengths, right? So we have two triangles here, and it says angle A and D are congruent to each other. And guys, on the test, it gets a little bit confusing, right? Because you have to take the test on the computer, and sometimes it's much easier if you can draw markings on the triangle itself, okay? So then my best advice to you is that maybe it would be a good idea for you to maybe copy down the drawing on a sheet of paper, so that way you can put your markings on it. Or maybe you can use your paper and then put it on top of your Chromebook, and then try and trace the shape. I don't know. But that is just some of the strategies that I would use. And it says given is what? Angle A and D. So angle A and D are congruent to each other, and that's this angle here and that angle there. And then it also says angle B and E are congruent to each other. B and E. So these are all angles that measure the same. Green is the same as green. Orange is the same as orange, right? And it says identify whether the two triangles are congruent using the AAS theorem. You know what this tells me? It tells me that it's going to be angle, angle, and then this side over here. Or it could be angle, angle, and then this side over here. Because they basically told me the answer is going to be congruent using what? The AAS theorem. And they already gave us two angles. So it's either this side or this side. Okay? And it says use the distance formula to compare BC and EF. They cannot make it any easier for you, huh? They even told you which two sides to compare. BC, which is this line over here. Oops, I can't draw straight lines. And EF. Okay? So we gotta compare and see if those two sides measure the same. Because if they are, then according to AAS, those two triangles are going to be congruent to each other, just like the question wants it to be. Okay? So then, how are we going to figure out how long they are? Do you remember doing this on the boards?
No.
Oh. So remember, you have to create a right triangle. Yeah, and so I said, some of you, I told you to draw it, and some of you like, oh, Miss Choi, I drew my triangle. And I'm like, what? Yeah, you cannot make a triangle like that. You have to make a right triangle, right?
No.
Meaning you can only go to the right, straight to the right, and then straight down. So now I have created a right triangle right here, right? Same thing over here. Go straight to the right and straight down. Yeah, so Mr. cannot draw straight lines. That doesn't mean that you should draw curvy lines as well. You can draw straight lines, okay? So now we have two triangles, and what did I say? We gotta count how many? 1, 2, 3, 4 here. And then count how many down? 1, 2, 3, 3. And let's see. 1, 2, 3, 4. Oh, that's 4. And then 1, 2, 3. That's 3 down, right? So we're using the Pythagorean theorem. In order for us to find out how long this is a right triangle. So we're going to use 4 squared plus 3 squared. And that equals this length right here. And I can't see the letters. It's EF. It's going to be EF squared, right? All right, so then if we square them, 4 squared is 16, 3 squared is 9, right? When you add them, 25 is EF squared. So a lot of people get confused over here. What do I have to do to find out how long EF is? How do you undo the square, guys?
Subtract itself.
silly. You have to do the square root. So EF is now equal to 5 because we cannot use -5 for the length. Now, I want to go ahead and find out how long BC is as well, but I know it's going to be exactly the same because look, I have 4 across and 3 down, 4 across and 3 down, the exact same thing, right? Okay, so I know that BC and EF are congruent to each other. Okay? All right, so let's scroll down and see what the question really wants me to do. Okay, so BC is how long? 5. EF is how long? 5. Therefore, they are congruent to DEF, right? And that was it. Let's check my answer. Of course, is correct.
What?
And we are done.
Alright.
Okay?